Another example from your book, page 201. Here we have an object of mass m 6 kilogram initially at rest. So V initial equals to O. Is pulled to the right along a horizontal surface by a constant F equals to 12 Newton. So we have the object initially at the position X initial, and I want to move this object to X final by F applied equals to 12 Newton to the right. Okay, and V initial equals to O. Find the speed of the block. We have to find the speed final of the block after it has moved a distance or after have a displacement of delta x equals to 3 meters. Here the displacement between the initial point and final point, delta x. Now we have only one dimension motion. You can say delta x equal 3 meters, or you can say delta x equal 3 meters I. Okay. We have the coefficient of kinetic friction, mu kinetic equals 0.15. Okay, you can use this mu when the object in motion. Okay, so here you have to choose the method. Maybe you can use the kinematics equations or Newton's law or the energy of a system. You have to choose the easiest method. Here you can use the total work done on the object equals delta kinetic energy. Why? Because by using the kinematics equations, you don't have time, you don't have velocity, you don't have acceleration. So I think by using this theorem, it's easy to find the speed. You know, on the object we have the weight mg, n, and f. We have friction n, mg, and f. Okay, anyway, you take in the situation between when we have emotion. Okay, here you can say I take the case when the object is between. Here you have the initial position, x initial. Okay, so the total work equal omega f. We have omega n equals to omega mg equals to omega, okay, equals to 0. Why? Because n and mg are perpendicular to the displacement. Okay, we don't need to do the calculation. And we have to calculate omega f. Here, as you know, f is opposite to the displacement. Here we have the displacement. So it's equal to minus f times d. And this f has the same direction with the displacement. So we write plus f times d. Finally, we get omega total equals to minus fd plus capital F times d equals to delta kinetic energy equal half mv final square minus initial kinetic equal to 0 because the object was at rest. Okay, we have to calculate v final. So v, we can substitute the values, minus mu kinetic times n d plus fd equals to half mv final square. I think mu equals to 0.15, n equals to mg. Okay, we can do the projection in terms of y prime y. The displacement d equals to 3 meter plus capital F equals to 12 times 3 equal to half m6 times phi final square. We have to calculate n. To calculate n, you have to do the projection in terms of y prime y. Okay, along y prime y, we have n in the positive direction minus mg equals to O because we don't have motion in the y prime because no motion. So n equals to mg equals to 6 times 9.8 Newton. We substitute its value here. We get V final square equals to 2 times minus 0.15 times n 6 times 9.8 times d, okay, plus 12 times 3, this one, over 6. We get V final equals to, you do the calculation, equals to 1.8, okay, 1.8 m per second. This is part A. Part B, now the force applied on the object has an angle theta with the horizontal. The question is, at what angle theta? We have to find the angle. At what angle should the force F be applied to achieve the largest possible speed after the block has moved 3 meters to the right? So we have to find the angle theta in order to have V maximum at the position X final. Okay? Okay. In order to have V maximum, at V maximum, we have kinetic maximum. We have kinetic maximum because the kinetic equals to half mv square. When we have V maximum, we get a maximum kinetic energy. Okay? Let's calculate the kinetic energy and we see later how can we get the maximum kinetic energy and we calculate theta. In order to calculate the kinetic energy, we can use the work kinetic energy theorem. Omega total equals to delta kinetic energy. Omega total, here let me put all the forces applied on the object. Here we have Fx, Fy, N, Mg, and F. You know, Fy, N, and Mg, here, Mg, they are perpendicular to the displacement. Okay, the displacement is to the right. So the work done by N and Mg and Fy equals to O because they are perpendicular to the displacement. Omega total equals to the work done by F plus the work done by Fx equals to the kinetic energy final minus the kinetic energy initial, which is equal to 0 because the object was at rest. Okay, you know, the work done by the friction equals to minus because it's opposite to the displacement. So here we get F kinetic times D plus Fx is in the direction of the displacement, so positive Fx D equals to the kinetic F. Here we have F kinetic equals to mu kinetic N and Fx equals to, if you take this triangle to calculate Fx, here we have to do cosine theta. Cosine theta equals to Fx over F. So Fx equals to F cosine theta. F cosine theta. Here we have to calculate N. To calculate N, we have to do the projection in terms of y prime y. You see here in the direction of y we have n positive plus fy in the positive direction, and we have mg minus mg, this one in the direction of j, equals to 0j. You know, you can write summation of fx equals to max, and the summation of fy equals to may. And you can write summation of f total equals to ma. Okay? In order to calculate n, you take just the y direction. We don't have motion in the y prime, so the summation of fy equals to 0 because we have no motion. No motion. And we don't need to put j. We have only one direction. So n equals to mg minus fy. And you know here also in this triangle, sine theta equals to fy divided by f. So fy equals to f sine theta. N equals mg minus fy minus f sine theta. Okay, we have the value of fx and the value of n here, of n. We substitute the value here, we get equation 1. We can write here minus mu kinetic times n equals to mg minus f sine theta times d plus fx equals to f cosine theta d equals to the kinetic energy final. As a final equation, we can write here kinetic energy final equals to minus mu kinetic mg plus f minus here, okay, we simplify this formula, minus mu kinetic mg plus f mu kinetic sine theta d plus f cosine theta d equals to, okay, kinetic energy. Now we get the kinetic energy at x final. The question is, what is the value of theta in order to have a maximum kinetic energy or a maximum speed, maximum velocity? We said in order to have maximum velocity, we when we say we have a maximum velocity, it means we have a constant value of velocity. At the beginning, at x initial, we had v equals to 0, and the velocity starts to increase. We arrive to the x final we get V maximum. We have to find the angle in order to have V maximum. When we say V maximum, it means V maximum must be constant. And at the same time, the kinetic energy also must be constant when the velocity is maximum, because it's equal to half mv maximum square. So the maximum of the velocity gives us the maximum of the kinetic energy. The derivative of the kinetic energy in terms of theta must be equal to 0, because this value is constant. This value is constant. The derivative of any constant equals to 0. Here, like this, we can calculate the angle theta. Okay. Here, d kinetic energy d theta equals, this is a constant, so equals to 0, plus the derivative of sine theta equals to cosine theta. We get f mu kinetic cosine theta d. The derivative of cosine theta equals to minus sine theta, so minus f d sine theta equals to O. We can cancel d and d, f and f. We get mu kinetic cosine theta equals to sine theta. So we can say here sine theta over cosine theta, we can put cosine theta here, equals to mu kinetic. Sine theta over cosine theta equals to tangent theta. So tangent theta equals to mu kinetic. So theta equals to tangent minus 1 mu kinetic. Mu kinetic equals to 0.15. We get theta equals to 8.5 degree. So this is the angle where the speed will be maximum and the kinetic energy will be maximum. Maybe I can ask you to find the maximum F applied in function of theta. You can say also, when we have a maximum F, it means we have dF over d theta equals to 0. Okay, here it's a simple method to calculate, to calculate the maximum value of any, the maximum of any value. You can get the derivative of this value in terms of theta or in terms of x, for example, or t. It depends the problem.